Hello everyone and welcome to .NET Core Central. In today's video, I am going to talk about collections and generic collections. The main focus of this video will be around generic collection because generic collections are way more useful and will be probably used almost every scenarios. So first let's start with collections, and there are four main variety of collection or four main category of collections that we can use. The first one is a list, a type of list. As the name suggests, it's a list of item. Second one is a dictionary, which is nothing but a list of key value pair. Third one is a queue, and fourth one is stack. So we'll take one at a time. First we'll start with list, and for list we will start with array list, which is the non-generic version of the list collection. So for declaring array list, we can do and we need to add the system.collections namespace for that. And for adding an item to array list, we can just do list.add. And for the array list, the main thing with array list is it can contain heterogeneous items or heterogeneous objects, which means we can have a string as the first item in the list, and then we can have an int as the next item, and it will work just fine. And then we can access these items using a for each loop. And we can do now. Here comes the problem also with a non-generic collection. Given that it is heterogeneous in nature, there are two kinds of problem that we might end up getting into. The first one is it can cause issues because it is an untyped collection. So when we are doing a conversion, we have to be very mindful of the casting of the data to appropriate type, and that can cause problem because you have to know exactly which type of object was added at which index of the list. So that's one problem. And the second problem is with respect to performance due to boxing and unboxing for value types, because when the value types are added to a list, they will be boxed and saved as an object, and when they are retrieved, they will be unboxed from an object type into a value type. So that is the main concern with a non-generic list. That is why we will in most scenarios end up using a generic list. So to define a generic list, we can do var and let's say we create a list of type string, and then here we can add only string type. We cannot add an integer or anything else. We'll get an error because cannot convert an int to string. We can do a to string to convert, or we can just declare it as a string. And this is a generic list. The generic list can be of any type, so it can be int as well. So here can be 1, 2, or it can be an object also. So let's say if we define here the list can be of type data as well, in which case here it will be a new data one, let's say new data 2. So we can define a general list with a custom object also. So this is the first type of item that I want to discuss, which is the list. The next type is dictionary. Now for dictionary also we can have non-generic dictionary as well as generic dictionary. Now we can run this application, and let me just change it back to int, and let's change it back to 1 2, and let's do a for each on the list one as well, and let's just copy paste the same console.writeLine, and after this one we can just do console.writeLine of a delineator, just to create delineator between the two console.write statement. And let me run this application now, and here you can see we got test as the first output and 12 as the second for the non-generic list, which is an array list, and for the generic list of int we got 1 and 2 as expected. Now let's discuss about non-generic dictionary, and that is called a hash table. And hash table also similar to the non-generic list. You can see that its key is an object and value is also an object. So the first key can be a string and the value can be 1, and then the second one, the key can be 2 and the value can be second, and then we can do dot values, and then we can print value here, or we can do keys and print keys here. So first let's print the keys, and then we'll print the values. And for the keys you can see first and 2 as the keys. Similarly, if we add values, we're going to see 1 and second as expected. And hash table has the same problem as, or same shortcoming as array list in terms of chances of getting error due to knowing exactly what type to convert into, as well as a performance issue. The generic dictionary is just a dictionary, and the key here can be string and value can be an int. And once we do that, we can see the second one has started throwing error, and at this point we can have a 2, and rest of the thing can remain the same. And in case of a dictionary, if we just iterate through the dictionary, the item is going to be a key value pair, so we can do a key, and then here we can do key, comma, item dot value. So this time we can print both key and value. And we can also iterate through the keys. As you can see here, it is printing the key and the value. And here we can also iterate through either the values or the keys and do it just like we did for non-generic version of the dictionary. So that's the next item. And then the third one is Q. Now there are a couple of things I did not cover, so let me cover those. The first thing is for the dictionary, if we have to remove an item, we can always do dot remove, and we can provide the key that we want to remove. So let's say we want to remove the first item. So now if we run, we're just going to get the second item in the output. As you can see, we just got the second item. Similarly, to remove all items, we can do clear. And if we call the clear, it's going to clear the entire dictionary, in which case we are not going to get any output from the dictionary because it's empty. So these are a couple of important methods of the dictionary. Now let's talk about the third one, which is Q. So Q is a fast in, fast out collection, as you can guess it from the name. So you queue item, and whatever gets in fast into the queue comes out fast. That's the main fundamental idea about queue. So here, if we just, instead of this list, we can declare a queue. And queue also can be non-generic as well as generic. Since they are very similar, whereas generic has more advantage, I'm just going to go with the generic queue. So for queue, we can declare a queue like this, but for adding item to queue, it's not add. Instead, you enqueue an item to the queue. And then, let me change the name. And then we can iterate through the item and print it. And if we run this application now, we can see 1 and 2. Now, apart from that, there is for queue, we can always do things like, if we want to know if the queue has, let's say 2, we can always do queue dot contains and so 2, and we can do console dot write line of that. And if we run this, we're going to see 2 true because it contains 2. And if we try here, let's say 4, which is not part of the queue, then we are going to get a false here. Now, one thing I did not talk about dictionary. In dictionary also, instead of, if you do a dictionary of the key and the key doesn't exist, we are going to get an error. So if we give a queue of third and try to print it, this is going to throw an error. So if we run this now, we're going to get an error here, and you can see we got an error is key item not found. For dictionary, just like we did here contains, for dictionary we can do something like try get value, and here we can give the key as 3, and then we'll give out int third, let's say, and we can get rid of this, and here we can do third, and here third should be just 0, which is the default value of integer because there is no third. But instead of third, if we give here second, then it should print 2 as the output because it would be able to get. So you can see we get 2. So that's essentially similar to contains in Q. In a dictionary, you can do try get value. That's something I missed. I just wanted to cover that. So that's the way the queue works. Now, if we want to remove an item from the queue, we can use a method called dequeue. But from the queue, we cannot remove a specific index because it's a queue. So if we do a queue dot dequeue, it is going to dequeue the first one because it's a first in first out, and then after that when we print, we're just going to get 2 in the output. So if we run this, we can see we got a false and then 2 as the second item. False is because it doesn't contain 4. Now if I just get rid of these, let me also just comment out this print out, and this one also. Now if I run this, I should just get 2 as an output as expected. And then what we can also do is dequeue removes the item, it also returns the item. So we can do console.writeLine, in which case it's going to print 1. Let me comment this out so that we don't print anything. So this statement or this console.writeLine, the dequeue is going to return 1, and that is what will be printed out. So now if we run this application, the output will be 1. Now if we don't want to dequeue, but we want to look into the item and not dequeue, we can do peek. So earlier when we did dequeue and we did console.writeLine, we'll see 1 as a part of dequeue and 2 as a part of the array. So if we run this, we'll see 1 as a part of dequeue and 2 as part of the array. But instead of dequeue, if we use something called peek, which is going to peek into the item, which is going to be the first one, we'll see that we are going to print 1 twice. Once as a part of the peek and second time as a part of this loop because it's not been dequeued. And that's what we see. We see 1 and then 1 again and then 2 as expected. So that's about queue. And the last item that I wanted to talk about today is stack. So just like queue, you can define stack. And stack is a first in, last out. It is just like stacking item. You stack one thing on top of another, and the last one, which is at the top, can only be brought out first, and then the first item, which is at the bottom, will be the last one to get out. Now let's rename this as stack. And for stack, it is not enqueue, it is push. We push item into stack. And stack also has a peek. And for the stack, when we do the peek, we'll see 2 as the first item. So it will print 2 here. And when we do the console.writeLine looping through the stack, here also we'll do 2 first and then 1. So if we run this now, we'll see 2, 2, and then 1. As you can see, this is what exactly we expected, 2, 2, and 1. Now, if we have to, instead of peek, if we have to get the item out, we can use pop. So this is going to get the item out and return the item. So in this case, we're just going to see 2 as a part of the pop will be printed out first. And in the loop, there will be only one item remaining, which is 1. So we'll see 2 and then 1 as the output. You can see 2 and 1 as expected. Now both stack and queue has the clear method. So if we do stack dot clear, it's going to clear out the entire stack. And if we try to pop, of course it's going to throw an error. So we can always do a try pop, and try pop is going to return a true or false, and we can have out int result. So this is going to print out false because it cannot pop anything. We cleared the stack, and when we look through the stack, this is also not going to print anything. So let's try and run this application now, and you can see we got a false, and then it is not printing anything. So as you can see, there are 4 main type of collection that we can use in .NET, which is list, which is just a list of item. Then we have dictionary, which is a list of key value pair. Then we get queue, which is first in, first out, and then stack, which is first in, last out, or last in, first out. So that is all I wanted to cover for today's video. If you like this video, please give me a thumbs up. And if you are new to my channel and you think you are getting value out of my channel, please subscribe to my channel. And thanks so much for watching this video.